So carbon dioxide and these other long-lived heat-trapping gases are pretty different as compared to some of the traditional pollutants that we think about in terms of things that damage our lungs, for example. So when we put CO2 into the atmosphere, some of it gets sopped up by the land, some of it gets sopped up by the ocean, but as it drops in concentration through time, the oceans become less able to take up heat. So that means that when we put CO2 into the atmosphere, the warming from that emission is nearly permanent, centuries and millennia out. So if we were to drop emissions to zero tomorrow, we've got this warming commitment, about 1 degree Celsius, 1.8 degrees Fahrenheit, temperature increase that we've seen since pre-industrial times. The commitment in the climate system means that we could see a few fractions of a degree more, but some of the commitment also will be in the fact that there's a lot of inertia in the oceans, and sea level rise also will proceed for decades and centuries, and that will be all the more so if we put more carbon dioxide and heat-trapping gas into the atmosphere.
So it's there's a lot of momentum baked into the system that's going to keep warming for a long time.
But it's critically important to recognize that maybe the fiercest momentum we're dealing with in the climate challenge is not necessarily that temperature inertia that we were just talking about. It's actually the inertia of our human systems. It's almost hypothetical to think about dropping emissions to zero tomorrow. We'd crash the global economy. So this inertia is our technological systems, our economic systems, as well as our climate system.